So the next company is NuEnergy Technology Corporation, and they've been around for a while. The founding technologist actually was a Brookhaven National Lab scientist, and they're really working on thermoelectric generation when you think about and you see the whole presentation. I think that's an exciting field. I think we've heard a lot of folks looking at that as an emerging industry. Again, very few hubs around the country working in TEG, but the possibilities are endless across so many different markets. So with that said, I'll bring up Eric Cooper of NuEnergy Technology Corporation.
I'm Eric Cooper, the COO. We'll have the CTO and CEO, Hector Guevara, at the Q&A. I'm here to talk about thermal electric generator, or as we call it, TEG for short. What I'm going to tell you today is we are a Florida-based company. We are patent pending with our TEG, which basically converts heat into electricity. We need about $300,000 to get us from where we are right now into production ready. And once we do receive that money, we're about 120 days until we can actually launch the product. The amount of opportunity for a TEG is so overwhelming, we had to be very careful about how we decided to go into our first market. So what we did was we looked at two problems that are converging into one general set of solutions. In the developing world, roughly 2 billion plus people have a dire need of electricity, and many of those people also need about 740 million homes. That converges into sustainable housing for a lot of these places because the environments are rural. Things don't work well with traditional infrastructure, grids, so on and so forth. That in turn gives us our first customer base, housing suppliers. I'll call that for short. From feedback we've gotten, many of them would love to be able to use heat as another source for electricity. They can then put products inside these structures that generate electricity. They can also take advantage of cogeneration by using it in conjunction with diesel generators or combustion plants that are actually spread throughout many of these locations, factories, timber mills, so on and so forth. Efficiency, of course. More efficient per unit of area means you can build smaller devices, or you can get more power from the same area that you're currently using with another solution. And of course, cost, both per watt in terms of buying it and in terms of installation, which is often dramatically more expensive than one might think. How TEG works, and this is greatly simplified. You can ask questions, of course, at the Q&A. And you will see actually one of our models right here. It looks kind of like it's out of 2001, and you cannot really see what's going on. So this simplified drawing hopefully will help. Basically, you have a hot side and a cold side. One is receiving heat, and in our case, we need 15 degrees Fahrenheit temperature difference or better to start generating some electricity. We use graphene is one of our ingredients in our special sauce, if you will. And there's a lot of nanotechnology stuff that I would let Dr. Guevara get into more detail about. But it basically works as such. Heat hits one side, excites the electrons, which will then jump past a barrier and be caught and trapped, contained, used, directed. And that's how we generate our electricity for the very layman. We have identified some very specific, what we call customers and prospective customers. And there's two different colors. We term one orders. This darker green down here, we have documents signed. These are companies that want their hands on our product first. If we can deliver the product, they are contracted to buy. On top of that, we have a much bigger prospective list. We are actively talking with these people. We have formal indications of interest. We have one or two companies that are actually working on getting sovereign guarantees in conjunction with governments. And as long as we can produce the product and deliver it, they are going to buy it. It totals to just under $1.2 billion right now for 5 years. That's cumulative, of course. So as I said, sustainable housing companies are our first target for customers. We have the largest one in the world already signed. They want our stuff for 3 projects. If we can deliver and it works like they think it should, there's a lot more on them alone. We have 3 companies that are working. They're small, they're regional, but they're working in conjunction with money from an NGO or a government. And we're excited to build both of those prospect lines. We're currently in talks with a global company that is now entering the sustainable housing market. And we have several throughout different countries that are regional or local. In other words, they're a lot smaller. Our sales and distribution is in many ways the same thing. We contract out the manufacturing, and because of the way it works, it's actually surprisingly scalable. We can bring on quite a lot of capacity in very little time, and we keep very little overhead. We can have it manufactured. Our independent sales reps are out in the field. We don't actually pay them except in commission. And then we have a small group who kind of direct their efforts that are under our payroll. We deliver TEG to the housing suppliers, often in central locations. They in turn interface with NGOs, governments, philanthropic groups, and even some corporations. So it's kind of an efficient way for us to get our stuff out and let them market for us as well. This is one example. This is a regional housing supplier that we have an agreement with. They are hoping we can deliver sometime before first half of Q 2014, Q2. In Ecuador, they are currently contracted for 5 sites. We've been asked to supply 12 megawatts of initial capacity, which is worth a little over $10 million in gross for us. And this gives you an idea of the kinds of environments we're looking at. I don't know if you can tell, but there is not much going on here. There is one little road, no transmission to get to this site where they're building houses. They need sustainable off-grid solutions. So our go-to-market strategy, we're starting in the Latin America and Caribbean region for a variety of reasons. We have a lot of good contacts. We have people very experienced in this area. We're going for sustainable housing companies, particularly ones that are in that market. This is also a rather virgin market, by the way. It is almost completely open in terms of potential. Leverage those customers to increase our sales and get new markets. Now, in terms of competition, we have 2 types as far as I'm concerned. These 2 I call our competition for dollars. These are technologies that are used right now. They are receiving the lion's share of the money. In total, well over $10 billion a year, as far as we can tell, just in this kind of area. As one would hopefully figure, since we put it in a graph, we come out ahead in pretty much every metric. So I'm going to highlight just a couple. Cost per kilowatt. This is total cost to install. We are definitely better than solar, but diesel can actually be much better. And a lot of people get tripped up on that until they stop to think. It's really the ongoing costs where diesel becomes a tremendous problem. If you think back to that little road, imagine transporting your diesel all the way there, let alone the fact it's not necessarily a helpful option. But diesel is, in fact, one of the highest cost sources of electricity for most of the developing world. And then I will bring our attention to efficiency. Our product starts at about 57% efficiency at a 15F thermal differential. Solar is less, and then to give you some ideas of what a good modern generator might do, 1/3 of a liter roughly for every kilowatt hour, and the cost can really add. Now, our other type of competition, they're not really in our market space yet, but they certainly could be, and there are certainly others who are working on things that could be possibly in the next few years. These are other forms of TEG, thermal electric generators. We have major corporations like 2.6. We have TEG Power, Telerex, and Green TEG, which has just popped up on our radar. To give you a sample of different options, I will just note that our temperature differential is what we know we can get 57% out of. These are according to the published optimal temperature differentials. So they can certainly work probably at less, but when you look at the wattage, we come out quite well at 20. TEG Power, by the way, you lose about 5 of these watts in the water cooling that they require. Our material, we're the only one that seems to be using graphene. We hope that continues. Our max temp looks to be much better, which means we can be used in a lot of cogen situations that a lot of others do not seem to be very effective for or usable. And as again I said, our efficiency starts at 57. I believe it's tested up to nearly 70%. And then our cost per kilowatt, or excuse me, cost per watt, we're modeling 85 cents. That's for our standard. It's like a basic solar panel. That would be our least expensive, and it gives us a reasonable margin even at that. Financials, these are times 1,000. So our gross revenue based on our in-hand stuff. Now this reflects both orders, as we call them, and prospects, but only those that we have actively engaged. This is not the total market. We expect a reasonably heavy hit of business, about 32 million in year one, which with our contracts in place for supply should be no problem to meet. Going all the way up to $422 million in change by year 5. We do expect this to grow. The largest company in the world of its kind, as they call themselves, their excitement alone leads us to suggest we probably do better. In terms of the whole team, I'll just mention that Dr. Guevara has been long known in thermal and photovoltaic industries. In fact, he's the person who designed and installed the first solar system in the White House under President Carter. I tried to put the picture on because it's funny, it's from the 70s, but it didn't turn out too well. Developed international market in solar products and also in the 70s, and he's founded 2 companies in the past, one of which he took public, and I believe he received in 2002 the Hispanic Entrepreneur of the Year Award in New York City for one of them. The rest of the team, what do? Well, we bring some experience with us. 50 years plus of innovation in sales and renewable energy, 120 years of entrepreneurial experience, 150 years in sales and business development experience, half of which is in our first target market alone. So, what do we need 300,000 for? It takes us from where we are right now. It gets us through all of the testing, certification, and to the point where it's ready for manufacture. We think we can have it launched within 120 days from funding. This is in part based in discussions with those manufacturers that we're looking at contracting. In the past, we've raised about $860,000, including the $10,000 prize. This, of course, does not include decades of research that basically we inherited when we got Dr. Guevara, and a lot of sweat equity. There are a lot of us who have gone for no paycheck to keep us lean and mean. Our exit strategy, we think, is going to be either an M&A, if the right, strategically viable, suitable, making sense type of partner appears. We're, of course, always open to an IPO if the market is right. So in sum, we have a game-changing, disruptive technology in our thermal electric generation. We have a vast, immediate demand that we've already identified. And 300,000 should get us a launch in the first quarter of 2014, and on our way to capturing at least $1.2 billion of gross over the next 5 years. Thank you very much. I'll have Dr. Guevara on now. And I apologize, I could not see if there was a card. That projector is completely blinding me on my glasses, so I hope I didn't run over. Sir.
So I have a ton of questions, but I'll try to make only a couple of them. I'm kind of really confused about the technical story, and I'd love to hear actually what the technology is. And here's where I'm coming from. No existing thermoelectric technology is anywhere close to being viable, and there's tons of people doing research in that space. So I'm trying to understand, it mustn't be thermoelectric that you're talking about. It must be something very different. And especially the 57% efficiency claim is clearly not a Carnot-based efficiency like the other efficiencies were in your competitive assessment table. So really, what is that 57% efficiency?
I'll be glad to answer that. What I did, take that back, was that as as a number of you were familiar with nanotechnology, what we did was I started working a number of years ago at Stony Brook University in BNL, that's Brookhaven National Laboratories out in eastern Long Island, on testing the graphene layer. And we started to do something with a process called chemical vapor deposition, where we actually started to put layer upon layer and heating it. As we heated it, we actually then started to utilize a special proprietary process to create a temperature differential between the heated layer and what we call the cold side. As a result of maintaining that differential, we also had certain meters, of course, with which we were able to measure the total amount of BTUs or the watts that we were getting relative to the coefficient that we had. You know, basically the input temperature, we were utilizing the Carnot equation. I'm not going to go into TC, in, out, and so on and so forth, but basically to answer your question, as a result of doing that, while maintaining a 15-degree temperature differential, we were able to pick up that we had 57% was the amount that we were picking up on the cold side from the circuitry that I had designed, utilizing something called Schottky diode, so that all of the current could only go in one direction and none would flow back or dissipate outside of the environment of the panel, which was a bench-tested panel that we had. I'll be more than glad to answer, and go over more specifics with you in the back there, where number one, and hopefully I can satisfy, assuage your interest and curiosity as to how we did this. It's something that, just to add a little, as Eric had said, to add a little something, about 35 years ago, I was on the roof of the White House just putting in the 32 panels that we put up there, and it bothered me, and I was speaking with Senator Bill Bradley from New Jersey, because I thought we had, basically created a change, wake up call, America. We're putting on something here which is going to take us off of this dependence. We had just come off of an oil embargo, and this was going to do the trick with regards to the photovoltaic and the thermal systems that we had put up there. Bill Bradley looked at me sort of whimsically, and because he knew it wasn't going to happen. 35 years later, here I am talking about, something that was going to take us past the 15% of efficiency, which is roughly what we get when we utilize photovoltaics. I could not accept that, and I've been working on that for the past 35 years, and I'm very glad to say that we now have a product that will do what I was inspired to do that long ago. So, thank you.
Are you doing anything special to the graphene? Are you functionalizing it? And how is the graphene actually being used here? Is it a coating, a film, a composite? Can you clarify it a little bit? It seems spectacular that you have these kind of results with graphene.
Right. The graphene that we were using based on a process with a company called Trion Technology, where we were able to actually do the etching, and we were actually able to do multi-layers, not just single layer. So as you can see again, when you go in the back there, if you visit, we have a piece of the graphene that we were using, and how we were actually putting it on a bed of copper in order to maintain a higher temperature, utilizing the copper as the bed, so that we could sustain a higher temperature for a longer period of time as we induced the transference. Another thing which is proprietary to our system is the fact that I figured out, in order to try to get a larger inducement, in order to get a higher flow of those electrons from the hot side to the cold side, if you go to the Patent and Trademark Office and pull down my patent, you'll see that we have strategically placed ribbons. And those ribbons are of a permanent magnet. And that permanent magnet that is strategically placed actually also further induces the transference of those electrons coming from the hot side over to the cold side.
And just to be clear, I mean, is this single layer graphene, multi-layer? I'm just trying to figure out what is different from your graphene than what we have seen in the industry.
We tested both the single layer and then we tested the double layer. With the single layer, we had a higher ampacity. We had a greater amount of current flow. The problem, though, was with regards to the insulation. So we're currently still doing the bench testing in order to go to a multi-layer, because we know that with the multi-layer we'll get a higher voltage with that heat, but it reduces the amount of the watts that we can get across, to the cold side. So that's something that we're currently looking to optimize. We're working on FEA, doing something called finite element analysis in order to determine which is the optimum, whether it's single layer or double, or possibly even a triple layer. So that's what we're working on.
If I heard you correctly, you're looking for a 300K raise, and I'm right here. Sorry. So you're looking for 300K, and you said you'd have modules in the field in about 120 days, and those would be UL registered.
That's part of, yes, the 300K would cover the UL.
And you think you can get them registered in 120 days?
I was going to say, Dr. B.R.A.V.O's got a lot of experience in this. I probably should let him actually answer this. But the short answer is yes.
Yes, based on, again, the bench testing that we've done. Sorry, I didn't know where that question came from. Thank you. We're currently communicating with part of the University of Central Florida, the Florida Solar Energy Center in Cocoa, which is where I've done some work before there for testing, and we're pretty sure that we can get the test results from there and then go to one of the independent labs, whether it's here in Florida or a couple of the certification laboratories like Redlift Laboratories that I worked with before out in Long Island, in order to quickly certify our product.
Can you explain to me, for your lead applications, what is the source of heat and what is your heat sink for operating the device?
The source here, as Eric was referring to all of those houses, our first market that we have targeted is the residential market, because there's such a large requirement for low-income housing throughout the world. Regrettably, those places where those houses are needed the most, there is no grid. So what we're looking at is at a solar radiation, just like with photovoltaics, that we would be able to utilize that incidence of solar radiation upon our TEG panels in order to produce. In all probability, although we're not going to get much into it, but we're looking possibly at a hybrid system where we may be using the sun, but in certain locations there may also be optimum usage for a small wind turbine to augment the amount of electricity in order to meet the demand load that you have in those homes.
And it may bear noting what I call our standard version is morphologically the same as a PV panel, so you can actually input one straight in. It's just, in general, the rule of thumb is you need a lot less of those arrays to get the same.
So then when you did your dollars per watt, is that dollars per peak watt, or is that the dollars per watt considering the actual capacity factor of the device, the amount of time that the sun is actually shining, that sort of thing, over the life of the device?
Yes, it's based more on the latter, based on the specific location, and that's going to vary, of course, based on the location, the total number of sun hours that we're going to get at that location. Once again, it may very well be not optimum to use the same sort of system in one location vis-a-vis a different location.
I have been told we are wrapping up now. I assume something about people starving, wanting lunch break. But we are booth 1, and thank you very much for your attention and your questions.